Good evening to one and all. It gives us a great pleasure to extend a warm welcome to one and all on behalf of Sri Venkateswara College of Engineering from the Department of Electronics and Communication Engineering for the final day of AICTE sponsored 3 days online workshop on personality development, career planning skills and entrepreneurship training under the scheme Samruddhi. In yesterday's session, we had Dr. Shobha Anand Reddy, Director Trends Bengaluru, addressed on career planning and entrepreneurship skills, and Mr. Deepak Puranik, co-founder Kridagala Bengaluru, addressed on selling skills. These sessions were very informative. We hope all the participants enrich their knowledge with ample amount of information on career planning, entrepreneurship skills, and how to work on individual skill set. We thank them once again for accepting our invitation and decorating this event. For the today's session, we have Mr. Harish Lingaiah, Senior Technical Manager, QualComm Bengaluru, with us. On behalf of management, principal, and from the head of the Department of Electronics and Communication Engineering, I feel so privileged to welcome Mr. Harish Lingaiah for this event. We welcome you, sir.
Thank you.
Sir will be addressing on latest trends in electronics and communication domain. This will be helpful topic for all the students who are willing to work on core electronics and communication domain companies. We request all the aspiring students willing to shape their careers on the core domain should make use of this opportunity to the fullest extent. Now, I would like to take this opportunity to welcome our session speaker to the participant with a brief profile. Mr. Harish Lingaiah is a senior technical manager with 20 years of overall experience and 10 years of team management experience in ASIC, SOC, and IPs development. His area of expertise in the development of video audio interface IPs and navigation processor. Sir also worked on ASIC, SOC microarchitecture, design, integration, verification, synthesis, STA, FPGA prototyping, and silicon validation. Sir has vast experience in collaborating with global teams and local adjunct teams. He worked on many silicon tape-out starting from requirements to port silicon validation. Possesses knowledge on multimedia, mobile SoC architecture, low-power design, clocking, DFT, and physical design. Sir completed Bachelor of Engineering in Electronics and Communication from Mysore University and obtained his Master's in VLSI Design and Embedded System from VTU. Sir work experience includes HCL Technologies from Chennai, National Semiconductor Bangalore, Marvell Semiconductor Bangalore. Presently, Sir working in QualComm companies as senior staff manager. With this introduction, I request Sir to take over the session. So please.
Thank you, sir, for your introduction. Okay, can I see my screen? Sir, can you see my screen?
Yes, sir. We can able to see, sir.
Good evening, all. I'm Harish. As sir introduced me, I'm currently working in QualComm Technologies, Bangalore, as a senior manager in the modem department. Today I talk about the job opportunities or career options in electronics and communication industry. What we have the various options today, and also in the end we'll talk about what are the challenges, how to overcome these challenges in the career development. After you join the your jobs in these industries, what are the challenges you face, how to overcome that. Okay, today's agenda is career options for ENC graduates, what we do in electronics industry, just to brief about what we do in the electronics industry, and then what are the job opportunities like electronic system design jobs, electronic component design jobs, customer support and EDA tools, and the challenges and the career development in the organization. Okay, so let's start the briefly. What are the various the opportunities or options available for the mainly in the ENC If I say ENC, it's also like nowadays we don't. Most of the companies doesn't differentiate much between the ENC, END, and TND. The electronics, electrical, and telecommunication and electronics. So mainly I put in the three broad categories. Core electronic job opportunities, where most of our ENC students, including me, who aspire to enter this domain, because we when we select this stream itself, we will dream about, okay, I just want to do a hardware job. I want to do a core electronic job. So most of the students belongs to this category, and in these we have options like electronic system design in the field of compute in the sense all the server or the laptop, all your personal compute devices, then the consumer electronics, all the your like a day-to-day electronic devices like TV, mobile, all those things, then communication systems, automotive, industrial automation, etc. We have many other fields. And also, another important domain here is VLS and IC design, then embedded software development, EDA tools development. Most of the companies for these domains, most of the companies prefer only these core streams like ENC, END, and TND. And also, for advantage for the electronics student is that they can also pursue their opportunity in the non-core job opportunities like machine learning, artificial intelligence, software development, other software development, and sales and marketing. For in these stream, in this domain, companies offer job for all other streams also, like computer science, mechanical, everywhere, who are have a good knowledge about the computer. So they also offer, but you need to compete with them. And also, several government organizations and PSUs also offer jobs for electronic students. The ISRO, as you know, the our well-known ISRO offers does very good satellite communications. They need bright electronic students for to develop their satellite communication systems, control systems, etc. The DRDO, which is mainly supplies the systems to the armed forces, they also develop communication systems there for their missile programs, and then they develop a communication systems, satellite communication, microwave communication system to the armed forces. That also required. So then in armed forces also, we have several job opportunities for the electronic student, that is to install or maintain these communication systems supplied from ISRO or DRDO. And then we have a PSUs where BSNL, MTNL, BEL, and BHL. So the good part is that most of these companies are located in Bangalore. We are blessed with this kind of a infrastructure, or organizations are in Bangalore. In BE and BHL do a lot of electronics, different electronic systems designs. They also offer a lot of opportunities. What we do in electronics industries, just briefly understand that, okay, how these jobs are offered, why we need so many electronics or engineers required in this industry. So let's understand a little bit about what we do inside the industry. I broadly categorize these what we do in our organization into five categories. The first one is electronic system design for various applications. What it means that first we need to identify we need to identify the any solution for the day-to-day job, day-to-day problems we are facing in our world. So like, okay, let's say I give an example. Uh, Example of my company, Qualcomm Technologies. The Qualcomm Technologies, how we started, I'll give a small story about it. In 1983, the one Korean aeroplane was shot down by a Soviet, means then the USSR, because this Korean aeroplane strayed into their airspace by mistake because of the navigation errors. So because of that, then the President of United States, Mr. Reagan, ordered to available the GPS, the Global Position System, or the navigation system, which till then it was used by the American defense system and the American Air Force. They ordered that, okay, this GPS is very that time it was very accurate. It was providing the accurate navigation system to their defense systems. So Mr. Reagan ordered, okay, um, uh, uh, let's allow the other civilians or other government organization can use this the excellent technology, so that we can avoid the this kind of a incident in future. So these created opportunities for many. In that, in 1985, three bright engineers, one of our founders like Irwin Jacobs, Mr. Andrew Wetterby. I believe you people know that Wetterby decoders. So, and another bright engineer. These three bright engineers took the opportunity, and they used this opportunity to create a tracking system, the navigation tracking system for the commercial trucks called Omni trucks. So what they've done is that first they built this communication system using a discrete components. So now they identify the problem, they see the opportunity, they define one system, electronic system. That is the this navigation system or location system, or locating the Omni trucks for their owners, where their trucks are traveling, when they how long the distance they travel, okay, to locate their tracks. That's called omni tracks. Later, by they successfully sold this many units of that. Then the US government see the capability of these engineers. Then they asked to build lot of defense communication systems. Like that, the company grown. Then later, after they enter into this mobile revolution, so then what happens is, initially they used to develop this system using the procuring the component from others. Then they started using their own component, they started building their own components using FPGAs. When the mobile revolution like evolved, mobiles are evolved day and day, and we need a very compact, very vertical of a small form factor and huge computing power in that mobiles. That's why they entered into a IC designs. They started building their own application specific ICs. We today we call it as ASICs or SOCs. So we started developing our own ICs. So we started as an electronics system design, and then we entered into this electronics component design. So we also design electron systems which for mobile applications, other application, and also we design whatever the components required. Our main components are the Snapdragon mobile application processor. Today we integrate almost five more than 5 billion transistors inside this latest Snapdragon mobile application processor. So these mobile application processor, as it doesn't the hardware itself doesn't work. We need a software for them as well. So most of our functionality for our electronic devices is divided into a hardware functionality and software functionality. We cannot do everything in hardware. We need a software that we call it as embedded software. We provide a powerful processor inside these hardware devices. Then the software development team will write a software for that, develop and deploy inside the devices. So we also need a embedded software development. Then once we have these devices, we need to deploy to the customer, or we need to sell to the customer, and then we need to educate the customers, and also we need a maintenance. When our customers see a problem, we need to address those problems. That's a customer support and maintenance. So to do all these above things, we need a good tools. We need to automate those processes. Then only we can do it in an on time and in an easy manner. So that's why there's another industry started called EDA tools development, like electronic design automation tools. That's another domain started with that. So these are the various jobs or various things we do in the electronics industry. Okay, so next we'll move into more detail about the electronic design system design. In the electron system, what we do is that defining a new application in the area of consumer electronics, communication, compute, networking, industry, and automobile. For example, defining what a new application. Okay, when the technology grows, we create new opportunities. One is like earlier day we used to use only desktops. Then the laptop came, then the tabs came, like that new compute devices came, then the mobile came, like that with the mobile there is a lot of IoT devices coming. So these, the company and the organization will have a bright teams to develop these new applications. The company itself will form these applications, so that they can or what you call, they can improve, they can provide the growth to their company, they can improve their profit, everything. So that's why every company will have a set up a team, that's called, we call it as a system team, with the bright engineers to come up with a new ideas, new applications, so that they can use our existing, or if required new ICs or new ASICs, we develop these systems. So in this, for example, if you say that what is the electronic system, the mobile phone is one electronic system, because the mobile phone is not made up of a single device. It is made up of a many smaller electronics components. We start with a mobile application processor, then the camera, then the sensor, then the display. So like that, all these electronic devices, each electronic device is a electronic systems. We call it as TV, security camera, any car dashboard, because the car is lot of how much it is automobile or mechanical parts it has, the same amount of electronics part it has. So then the entertainment system in an airplane, wireless router, CT scan, like that we can give many examples. All these are the electronic system. So these are initially, first we need to define how it should work, what, how to address our problems. Then once we have the blueprint, then we need to do it in a physical manner. We need to prototype. That we do using a PCB board design, and we need a lot of engineers in this area where we do board designs. All electronics and semiconductor companies have position for this system designer. So we can give some companies which offer this kind of a jobs are Apple, Sony, Samsung, Intel, Qualcomm, Broadcom, Siemens, etc. Then coming to the electronic component design. So to build a electronic system, we need various components. So what are those components? I um, classified into three categories. One is digital ICR ASIC. In this category, I'll just go back to the previous one. In this electron system, roughly around 10% of jobs offered in this are offered in this category. In the electronic component design, this is the one more important and wide domain where around 30% of electronics job are offered in this category. This IC design, which most of the most of the even the ENC students are aware, they are dreaming of entering this domain. So these digital IC is comparatively fairly compared to analog and RF design. It is a pretty less complicated, but it is the most most of the companies does this, and it offers more jobs in this domain. So in this, within digital IC design, we have again subdivided into various category. First, we need to develop algorithms and concepts. What exactly we do in this? So that we generally we develop this using MATLABs. I think most of you are aware of the MATLABs or C, and we build models with this. Then we need to take these algorithms or models concepts into a hardware specific languages called Verilog and VHDL. We convert those ideas into a behavioral code using Verilog and VHDL. That's a front end design and verification, what we call. In this area also, this is the vast area and require more engineers in this area, front end design and verification. Once we have a front-end design and verification, we describe the hardware functionality in a Verilog and VHDL language, that we need to convert it into a transistor level, or the what we call the stick diagrams. That we use again the tools, and we convert that, we call it as a backend. So here also a lot of our job opportunities. Then we, after once we have this, then also along parallelly we need to prototype what we do, because once we fabricate a IC, it's a costly affair. Fabricating IC is costly. To fabricate it requires millions of dollars. That's why we need to make sure that everything, our defined functionality, defined timing, everything is works before we fabricate a IC. So that's why we something we call it as a prototyping using FPGAs. So we do a lot of validation and prototyping using FPGAs. So this also domain require offers a lot of opportunity. Then after that, once we fabricate ICs, then we require a post silicon testing. Before the post silicon testing, we build our systems. Like if it is a TV or mobile, we virtually build those systems using PCB boards. Then once the our IC is manufactured, our ASIC or SoC is manufactured, we put those in these systems, and we test all corner cases, all the applications required. If it is a mobile, we will check. Okay, so we will run all kind of 5G, 4G calling, all the video testing, all the camera testing, everything we do before we finally sell it to our customers, like who would build the mobile phones. Like that, yeah, we need engineers to do this testing in our labs. Then comes to the analog and RFIC. So you know that all the what is which functionality goes to the analog, which functionality goes to the RF and digital. Most of the analog to digital converter, digital analog converters, all the power amplifiers, all those things cannot be done in digital ICs. It will be separate ICs. We its technology is slightly different than digital. Um, it is required a very careful design. So in this also offers job opportunities that we require engineers for to do a design and layout of analog and RFIC designs. Then there is a certain companies or organization which develop the sensor and display, like all the touchpads, all the gyrometers, all our temperature sensors, all the light sensors, then the display. The display today we are evolved from the LCD today, OLED, AMOLED. All these technologies is developed by engineers. We need a people over there. All the semiconductors company offer the above jobs. We have Intel, Qualcomm, Broadcom, NXP, Nvidia, Samsung, TI, Xilinx, Wipro, and SCL. The good part is we are in Bangalore. The Bangalore contains most of the top 100 semiconductor companies have their at least have their offices or the development centers in Bangalore. For example, the big companies like Intel, Broadcom, NXP, Qualcomm, they have at least 25% of their workforce in India itself. That's a big advantage for us and big boon for us. Okay. Next we go to sorry, the embedded software development. As I told you, the all our hardware devices will include both software and hardware. We can't do all the functionalities, everything in a hardware itself. For example, in a mobile device or a TV, all the video processing or the image processing generally we do with the software. We will have a very powerful DSPs and powerful DSPs and all the processors, which software team will make use of them and build a software on that. So these embedded software, what is difference between embedded software development and the regular software development? These software is directly put onto a electronic device, and the engineers who require engineers who are developing need at least some basic knowledge about this hardware. Most of the companies prefer ANC graduate to do this for the embedded software development. Sometimes we also recruit CS graduates. These candidates needs to know a good knowledge on the microprocessor, microcontrols, and the operating system. That anyway, it's a backbone for electronic students. So that's an advantage for the electronic students because we study a lot about the microprocessors, microcontrollers, and sometimes we study about the operating systems. All electronics and semiconductor companies need large number of embedded software engineers. Example, Apple, Sony, Samsung, Intel, Qualcomm, Broadcom, Siemens, Cisco, Google, Robot, Bosch, Honeywell, etc. Nowadays, like most of the our this one, like for example, you take a Amazon Echo or the Google Home, this audio assistant devices. In these, the hardware is very minimal. We have a powerful processor in this. All the voice recognition, when we say OK Google or Alexa, these voice are recognized. Whatever we talk, it is all recognized. We have a microphone and we have a powerful software in it, the processor in it. Through the microphone, the processor capture the voice, it will do a processing. All the machine learning, all the artificial intelligence are built in that. It's all in the software. So we need hundreds of thousands of embedded software development engineers to do these jobs, to develop this such a intelligent software. So these devices just take our voice, process it, and then recognize, they convert into a text format, then they go into a search engines, they search what we ask, then they give you an answer. If you are asking for the weather about today, that way first it has to convert into a text format. Your voice has to be converted into a text format, then it go to a search engine, it search for today's weather in Bangalore, then it gives back through a voice again. So these most of the processor is done in a software. So that's why nowadays this requirement of the embedded software means the software engineers is more and more, and almost 40% of jobs are electronic jobs are in this category. So we need more embedded software engineers than this IC design or component design engineers. Next is the customer support and EDA industry. As I mentioned that once we develop our components or the systems, we need to sell it to a customer. For example, when we develop an application processor, we sell it to a this device manufacturers, like who are develop the Wi-Fi routers, who are develop all the mobile phones. We sell it to those. First, we need to educate the customers. We need to explain the customers what are our device capabilities, what are our processor capabilities. So we need a dedicated team which can do this kind of a job. If you directly selling devices again to the customers, all the retail customers like our us, again the customers we need to support the customers whenever we have a call centers where let's say you sell a laptop to a any customer, that we give a service to free of cost to service to 1 or 2 years. Then we need to make sure that the customers we solve their problems. So we have to, every company has to have a dedicated team called customer support. They no need to have a deep knowledge on the inside hardware. At least they need to have all the what are the capabilities of devices, what are the some troubleshooting capabilities they need to have. And that, so most of the companies need to have a team, the customer support team. And next, another big industry is the electronic design automation. As I said, okay, to develop our ASIC or even our electronic systems, we need a lot of tools. For example, for our Verilog simulations, we need a Synopsys VCS, a Synopsys Design Compiler for the synthesis, etc. So these we have several dedicated companies which develop these EDA tools, and they also offer like thousands of jobs. Unfortunately, we have these EDA companies as well in Bangalore. The big names are Synopsys, Cadence, Mentor Graphics, etc. These companies, their main job is to develop this EDA tool. They do a lot of R&D, how to, like, because nowadays the IC technology or the ASIC technology is evolving very fast. Now we are in the era of 3 nanometer, 4 nanometer, or 5 nanometer. Like in 5 years back, we are around 20 nanometer. These are not 20 nanometer, sorry, 50 nanometer. So these technologies, these nanotechnologies, evolving fast. So to in the same phase, these tools also need to evolve. They need to support these newer technologies. That's why it has to go parallelly. That's why they also spend like a lot of money on the R&D. So they need engineers for their R&D teams. They need engineers for their testing teams. They need engineers for their support and maintenance teams. Okay, so far we talk about what are the job opportunities in our electronics industry. So I'll just recap what are the opportunities now. So we have the five different categories: electronic system design for the various applications, component design means the IC design, then software design, customer support and maintenance, and EDA tools and development. So most of the big companies will have separate teams for all these things. They need all these categories. This one and the big ticket domains are this component design means the IC design and the software design. So these two categories offer more jobs. Okay, so let's say you got this core jobs or this your dream jobs of joining a electronics industry or you joining any semiconductor industry. Now, once you join, what are the challenges you generally face? How to overcome those challenges? Okay, then by overcoming these challenges, how to build our careers here in this organization. Okay, I'll talk about key points. Be patient. What it means that when most of the new companies assign low key tasks like testing, QA checks, documentation, scripting, etc. to new joiners, no company will give you all the high profile jobs or all the critical jobs to the new joiners. They also need, yeah, based on your academics records, based on your college where you studied and all, we also have we get some kind of a confidence. But until we really test you, until really know how you well you work, how smart you are, we need we don't assign the key critical jobs directly to you. So we assign the initial low-key jobs to all the new joiners. We want to evaluate your capabilities. That's why we assign this. But some lucky candidates will get the all the IKE jobs immediately, but most of the company don't. So the all the fresh graduates or the new joiners need to have a lot of patience. Need to prove themselves whatever the job they get, whatever the job they assign to them. They need to perform well. They need to accomplish them very well, and if required, apply some innovation there and then need to accomplish them in the on time whatever the time they assign. So that's why you need to have patience in initially, at least in first one in big companies 1 or 2 years you get mostly this kind of a work. Once we build a confidence, once we prove ourselves, then we start getting a critical jobs, we start getting some new work or some R&D work. So till then we need to have a patience. Next, the flexible and hardworking. We need to be flexible. We cannot say that, oh, I don't I only want to work develop a Varela code or a VHL code. I don't want to do any testing. I don't want to do any documentation. Not like that. Because if you take one IC design cycle, the only the design or the development or coding part will be only 25 to 30%, and the rest of the 70% is that quality checks, testing, integration, documentation. So all the engineers should be flexible to do all this kind of a job. And if you are picky, then it's difficult. It's difficult to survive. We should be ready to do the. We should be flexible to do all this kind of a work. We and next, hardworking. Initial days, we have to perform our task. We have to complete our task along with learning. We mostly, though we study the basics in our engineering course, we will have a basic ideas, but most of the candidates will not ready for the industry to directly start working on the industry. they need a training, they need to learn some new tools, they need to learn some new process. And yeah, a lot of companies will have their own process to streamline their all the work. So we need to learn their flows, process, tools. That's why initial days you need to spend time on learning as well as performing the jobs. That's why we need to do some hard working. Once we people after getting the job, after joining they relax and they lose the track. But at least initial days we should be hardworking. Then that will be good for the career growth. Then self motivation. In the large team, let's say if you're lucky, if you're in a small teams where you'll get all the guidance, all the follow-ups and all. But in if you're joining a large teams where mix of seniors, all the middle levels and the juniors, these managers or the leads will have a less follow-ups, because in many companies these leads and managers will there have their own headaches, like meeting the timings, meeting the goals, like meeting the sometimes requirements will be changing. They have to tackle all those problems. So they will have less time in following the new journeys or individuals. So that time, let's say most of the managers will say that they will initially, once the project starts, they will assign you all the tasks, they will give the deadlines and leave it. It's not like in the if you take in the classes or college, you will have all the regular tests or assignments, periodic tests, periodic assignments, and then midterm exams, annual exams. That makes you like that is kind of a follow up you. So even though you don't want, because of these regular assignments or tests and exams, you will be forced to study, you will be forced to perform. But in companies they will assign the jobs and leave it you, and then it is your self motivation. Then the managers will comes towards the deadline, they will come and ask you, hey, whether you are completed your task, whether you facing any problem. Till then some company some manager may not ask you. So then it's your duty, it's your self motivation as to drive that to accomplish and complete the task. So the self motivation is very important once you join the organization. Here, yeah, some managers which will always monitor, always follow. Some may not do. So this is very important. Then constant learning. So you need to be keep updating the technologies. You need to be like you need to have a constant learning once after you join. You need to see that what are the latest technology, what are the latest trends. You cannot be outdated. Let's say in case if your organization doing some still using outdated tools, or you are working in outdated technology, that you need to be aware. You need to connect with your people, you need to connect with the keep looking at the various journals, various what you call the materials available in the uh, internet, everything. You should be aware of that, because let's say if you not working on a latest trends, your job opportunity will be less. Let's say if a company gets into a problem, then you have to switch your job. If you're not updated to the till date, or if you're not using on latest trends, technologies, then you will be difficult to get a new job. That's why we should be constantly updating ourselves with respect to the latest technologies and trends. That is one thing. And also, when we are doing our jobs, we should apply our innovations. Let's say when certain jobs or tasks are assigned to you, let's say they ask you to do a certain like improves ask to do a module design or any component design, some circuit design. You have to think that, okay, this is existing one. What better I can do? What improvements I can do? What, let's say, can I improve some area savings here, or can I improve some power savings here, or they can make it little faster this design. So these are the ideas we have to keep thinking. So the companies also expect these innovations or these ideas from the youngsters. Many company promote that. Many companies, like most of the companies, most of the companies, they at least they ask the engineer to spend 10 to 20% for the initiatives. They every year they say that, okay, this is the regular job. What is your initiatives, or what is your new ideas you come up. So for that they respect a lot. You will get rewards, you will get promotions, everything with that. So that's why it just yeah, you need to always think about it. That's a very like a trend in the industries. Next one is that we need to maintain our professionalism and ethics inside the organization. That's very important. We should, okay, when we communicate with others, when we have to following the guidelines of the companies, following that, okay, ethics of the companies is very important. One important every company is required from the individual is that maintain the confidentiality of their uh, properties, IPs, intellectual properties. That is very, very key. You cannot share the work of your, whatever the work you do, whatever the code you do, whatever the designs you do, you cannot share outside the company. Sometimes even we cannot share our work or the diagrams or our code outside our teams. For example, in Qualcomm, as I am in a modem team, I cannot other team members don't have any access for the designs of a modem. Even we cannot share. We are prohibited by sharing this. And so this is the ethics or the professionalism we have to maintain within the organization guidelines. This is very key. Many, at least every company face this, and most of the companies, these incidents happens, and the punishment is very severe. They sometimes just a termination of jobs. Sometimes even it goes to the legal procedures. So that's why maintaining a professionalism and ethics is very, very important in the companies. And also, if you make this any mistakes there, it will spread. The world is very small. It will spread, and it will be difficult for you to get a job outside also. Yeah, so having said, these are the challenges, but if you overcome all this, yes, the career development will be there. If you will build a strong career in these organizations and this. So I talk about all the job opportunity within the electronics industry and all. As well, as you know that you have other opportunities like competitive exams, like you can take the Indian industry, this engineering services, or you can, as well as you have the career opportunity in the teachings, research and R&D sector. Like you can join the premier organizations like ISC or IITs, where you can do a lot of research and all. So there are other opportunity as well. So this is similar to other streams. Yeah. So this all about the today's topic, which which I talk about the career opportunities and the challenges. Yeah, let's see the any questions from you. Thank you, sir.
Thank you, sir.
Yeah,
Thank you, sir, for your informative session on latest trends in EC domain and job opportunity. Sir, addressed on what are the different roles played by EC engineers in various domains. Sir, addressed on electronic system design, electronic component design, digital IC design, customer support, and EDA tools. Thank you, sir. So
welcome.
now I request dear participants, if you have any queries, means you can post in the chat box so that we can circulate that to the sir. Dear participants, if you have any queries, means please put it in the chat box. Just a minute, sir. We will be
Yeah, yeah, sure, 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 sure.
Sir, there is one question.
Hmm.
How to bridge the gap between industry and academics?
Okay. The industry and academics, see, this is the role of all three people, like the students, the college, the management of the college, and the industry. So where the nowadays, like compared to the previous, nowadays the academics that what you call the syllabus of the is better now. They adopted the latest syllabus, latest technologies in the syllabus. But even the college or the students has to be pick up something like okay, learning the EDA tools at the college levels when they are studying. You will have all the evolution version or the student version of the tools. So it's better you if opportunities you get, you learn those tools uh, and attend a good workshop conducted by industry bodies and all. And yeah, so in the college also sometimes conducts all the workshop like this. So by doing this, yes, we can bridge the gap.
Thank you, sir. There is one more question, sir. How do you suggest us to prepare and crack core company interviews?
Yeah. See, I mainly talk about the semiconductors company opportunities. That's where this core, most of the core jobs are received. So the basic things is from beginner or the new graduate, what we expect. So I'm also went as a part of a many recruitment team. What we expect is we expect what exactly you learned in your college days, what exactly you learned in your engineering college. So we want all the basics. We want mainly on the basics. For example, we need a analog circuits, digital circuits, microprocessors. We don't expect all the programming, or let's say we don't expect all the Verilog programming or C programming and all. We check your understanding about the basics. We need to we check your the like how the transistor works, how the what are the characteristics of transistor, how the CMOS works, how the microprocessor works. So we want to check this understanding that. So as long as you understood your engineering subjects very well, then most of your preparation is done. And also we also look at your curiosity, how well you are understood the latest trend, what's your understanding about the latest technologies. That also it added advantage if you are aware of all the latest technologies trends. That gives means your smartness or your curiosity. So basically, what I say is that you study your engineering subject, all the core subject very well, you understand very well. That most of the preparation is done there.
Thank you, sir. There is one more question, sir. What is Qualcomm is looking from the freshers, sir?
Yeah. So Qualcomm, if we are recruiting for a IC design, let's say either it's a digital design or analog design. What we do is that one is that your the subject knowledge, how well you understood the all the basics like digital and analog and digital circuits, how well you understood the microprocessor. Then we also look at your logic thinking. So because we generally give the lot of logic questions to crack that. And also your this one like attitude also we it's important. So basically logic analysis, your basic knowledge on the electronic subjects, it's what we look at while recruiting.
Thank you, sir. And one
And,
more question,
and
sir.
one more thing, sorry. So, and also
Yes.
we expect basic understanding in the Verilog and VHL, C and the Unix. This is a must. We don't need you know to no need to be an expert in this. At least you need to have basic understanding. Where once we start giving a training, you should be able to pick up quickly. That's what we also look at that ability.
Okay.
Yes.
Thank you, sir. And there is one more question, sir. In future, can we expect EC core companies will be coming to India?
Yes, as I mentioned that in Bangalore, in India, most of the top 100 semiconductor companies are there. If you take the top five companies, the companies are Intel, Samsung, Broadcom, Qualcomm, and Nvidia. They are already there, and they have, more, close to some companies are close to their 25% of workforce in Bangalore and India. So yes, the companies still coming, and no need to wait that we already have many companies established in India. And also there now what we are looking is that how fast they are increasing their strength in India. So yes, they are increasing the strength. You can look at that. Whole the ring road is like a Silicon Valley, so you can see that every new companies is coming up on the our ring road. Yes, they are coming, they are
Yes.
increasing their strength in India.
Yes, thanks. This is from my personal interest, sir. So, how many programming languages as a EC engineers has to know, no, sir? Because every time the students will be having in dilemma. So, how many programming languages we need to study so that we can get it into the core companies, sir?
Yes, sir, it's a good question. See, as you know that most of the high-level language, C is the basics, C and Unix. So this and most of the embedded software is developed on the C and C++. That's all. You don't need to learn many languages like a software teams like a Java or other things. The C and C++ and Unix is the bread and butter for the embedded engineers, embedded software. For the ENC, these Verilog or VHL, no need both. At least one of that is required, and also you need a basic tool knowledge on the, let's say, any this AutoCAD tools, or this the design tools, or any simulation tools like VCS or something. So if you have a couple of because other industry tools are very costly. Most of the engineering colleges or organization institutes cannot afford that. So we'll at least a few of them. There is a evolution version or free versions are there. If you are aware of that, that is good enough. And having MATLAB knowledge is added advantage if you have tools like MATLAB. If you know that, it's a good advantage to enter the this core industries.
Thank you, sir. And this is from the faculty, sir, one of the faculty. How to grab attention of the students to concentrate on core subjects as students feel EC is very difficult.
Uh, as I am a EC engineer, I never felt this one. At least what happens is for us in my career also, even I completed 20 years. I never bored of my work because in our core this electronics or this core companies, what the interesting is this: we day to day not just reading, we work on the hardware, the live devices. That makes more interesting. So what I say that is you guys need to add more practical, like rather than just studying, we study with the practical or the at lab. It makes more interesting to the students. That's what. So we spend at least 10 to 20% time our time in some engineers spend most of the time in the labs, but at least we spend some time in our lab. Let's say we design something. Let's say I design any. I once I used to design like a HDMI or the display port things. So if I design such a component, if I take it to the lab, prototype, and get a output, get a display out of that. So that's like that joy will be there for many days. Okay, so you'll pursue. So like that, if you whatever study you make an experiment in the lab, you can apply those studies in the lab. That makes more the study more interesting. So I say that you make more practical. That makes a student interesting.
Sure, sir. Thank you, sir. The last question, sir. Why less opportunities in the domain of VLSI in India?
I think I don't know. I would say that this question is wrong because we see a lot of opportunity. See, when I entered my career like in the 20 years back, we were like tens of companies only there. Now you see the hundreds of company. For example, I'll give it, the strength of Intel in Bangalore campus. It's close to the 20,000 people are working in Intel campus. So most of these people are working on VLSI. So don't you think that number is a big, like that we have a big number? Okay, so this is a big number. The thing is that maybe the fact is that these companies goes to the most of the campus recruitment, everything goes to these premium institutes like IITs, NITs and all. That's why our engineering college feel that okay, we these companies doesn't recruit, but they do recruit a lot. For example, QualComm in India, we have 10,000 engineers in India. So this, like, we have all the numbers in thousands. So yes, we have a big opportunities, big numbers in VLSI also. Only thing is that we need to find a way to enter this industry. Okay, maybe what we do is that not we no need to directly enter the semiconductor industry. There are a lot of service industry like Wipro, SCL Technologies, and all. So they offer the like workload, means they take the people, they train the engineers, and then they send these engineers to, or they take the work in on contract basis from the product companies like Intel, TI, or this one, and they develop. So if we are not able to enter the semiconductor industry, big semiconductor industry directly, we have a opportunity where we start working in the service industry, and then slowly we prove ourselves and then enter this. So there are many ways. There are a lot of opportunities.
Thank you, sir. I request sir finally to give some suggestions for the upcoming engineers on what concepts or on what subjects they should concentrate more, sir, so that they will get into core companies, sir.
Yeah, so if you want to get into core company, I say that you start with your CMOS, you start with your transistor diodes, build your understanding very well. Then next level is the digital circuits, your computer CO, computer organization. You should be, see, if somebody asks you, okay, what are the different types of memories in the any computer? You should be able to ready. Okay, there's a dynamic memory, there is a flash memory, there is this, like that. You should understand that. That's a basic stuff. You no need to be aware that okay, what is the snapdragon, what is the number of transitions. That is the high level thing. You no need to have that kind of a knowledge. Okay, what is the OS it is used, okay, whether the Android O or Android G or Android N is used in latest mobile. That is not the things. What we look at is that the basics we look at, and also your problem solving skills, and also we give your logic analysis, logical thinking, what we call it as. Okay, so finding a multiple answer for a same questions, that's the ability and the debug skills. This is what we think about it. So you have a thorough understanding of your subject. We know that most of the engineering in the engineering colleges, what the subject they taught, we pick up one of the subject and ask the questions in that. And also you should be aware of the latest trends and technologies. Let's say you know that okay, what are these 5 nanometer, 10 nanometer, okay, what nanometers, you know that. So we just generally ask that. That is a good. And also knowledge about these tools like MATLAB, any synopsis or cadence tools, it will be added advantage. And also, and this most of the semiconductor companies works on this DSP, digital signal processing, because we need a we develop lot of algorithms, digital signals processing, because all the video, audio processing, everything based on the DSP. So DSP is a, still even today is a key. If you have a good interest and understanding of the DSP, is easy to enter this code companies. And also this machine learning and the artificial intelligence, these applications is also good. If you have a knowledge on these, is an added advantage to enter this core companies. So be very good in your subjects, and also be have a like a understanding of this, like the industry using tools or flows or processing, whatever possible, how much possible you get a knowledge on those, it will help to enter this industry.
Thank you, sir. Thank you for your valuable information, sir.
You are welcome.
And I request Dr. Shobha Madam to join the valedictory session. Please, ma'am. Now we come to the end of this 3 days online workshop. I would like to welcome Dr. Shobha Anand Reddy, Director Trends Bengaluru, for this valedictory session. Welcome you, ma'am.
Thank you, sir.
It's my honor and privilege to conclude with vote of thanks for AICTE sponsored 3 days online workshop on personality development, career planning skill, and entrepreneurship training from 8th to 10th August 2020 under the scheme Samriddhi, which will be organized by the Department of Electronics and Communication Engineering, Sri Venkateswara College of Engineering, Bengaluru, Karnataka. At the outset, we would like to thank AICTE New Delhi for sponsoring the program under the scheme Samruddhi. On behalf of management, principal, and from the head of the Department of Electronics and Communication Engineering, we would like to thank for giving us an opportunity to conduct this event under SVC umbrella. I would like to express our sincere gratitude to our ever-driving force, Honorable Chairman Sri V. Muniyappa Sir and Chief Executive Director Dr. Shashidhar Muniyappa Sir for their constant support and suggestions for making this program grand success. We would like to show our deep felt respect and gratitude to all our keynote speakers, Dr. Shobha Anand Reddy, Director Trends Bengaluru, Mr. Deepak Puranik, co-founder Kridagala Bengaluru, and Mr. Harish Lingaiah, Senior Technical Manager, QualComm Bengaluru, for accepting our invitation and sharing their experience and enormous amount of information related career planning skills and entrepreneurship skill set and career opportunities in EC domain. We hope all the participants enrich their knowledge and will make use of it in shaping of their future. On behalf of all participants, I take this opportunity to thank once again all the resource person. Now, I request Dr. Shobha Anand Reddy, Director Trends, Bengaluru, to address the participant regarding what are the next steps to be taken by the students from this event. Ma'am, please.
Yeah, good evening all. First of all, I'd like to thank Harish for a very wonderful session, and I hope all the students and faculty have benefited from the session. Our whole objective of organizing this program was to not make it like the usual communication skill kind of a program, but then we wanted to add a little bit more information to the course and give you the current strategies that you could take up as well. So I hope we have succeeded in that effort. And I'd like to remind all of you all one statement which our former President Abdul Kalam made. All of us may not have equal talent, but all of us have equal opportunity to develop our talents. And you are at the cusp stage where you are right now students, and then in another 1 year you're going to be thrown into the work sector. You have to start finding jobs for yourselves. Some of you may find jobs and some of you may opt to go for research, or some of you may opt to go for higher education. Whatever you choose, please maintain basic integrity, work ethics. That's the most essential skill you must have. That's integral to you. That is not something which somebody can fill you with. You can't pick it up from somewhere else. That is something that should be inbuilt within you. And then you have various opportunities to pick up various other skills that are essential to get your jobs, as highlighted by Harish, and also Deepak has spoken extensively about having a proper mindset, owning your mindset to ensure that you grow in your career, and have that kind of growth mindset, and try to find a balance between your passion, your goals, and your profession. That's most important. When you don't have a balance between what you like to do or what you're doing, that is where a lot of conflicts on the mind start. Do not allow for something like that to happen. Always make sure that you pick a job that is the core of your heart. That's very, very important. And till now, maybe some of the faculty have said that students may find it difficult. It's natural as a student because your mind is focused on several other things. you may not be, finding the subject easier, but then as Harish said, once you start involving and then finding joy in what you're doing, I'm sure you will find that happy moment, and you will find that that is what you want to do, and you will be able to successfully accomplish whatever you aspire to do. So I wish all the students and faculty all the best, and please reach out to us for any support or help. I've heard that some of you have reached out to Deepak already to ask him certain questions on real life situations, and I'm sure he's helping you all. So from my team of Harish, myself, and Deepak, I wish all of you all the best and good luck for your future. Thank you very much. Thank you, SPC, for giving us this opportunity. Thank you, sir.
Good luck.
Thank you, ma'am. Thank you, sir. Thank you, ma'am, for your motivational words. Now we would like to thank our principal, Dr. Suresh sir, for inspiring and motivating and giving us a platform to conduct this event. My special thanks to our beloved Dr. Shivashankar sir, Professor and Head Department of Electronics and Communication Engineering, and Dr. Keshav Murthy sir, Professor and Controller of Examination SVC Bengaluru, for their constant support, motivation, and guidance throughout this program. I would like to thank the main stakeholder of this program, dear participants, for your continuous support and positive feedback for this event. We are so happy that some of the students are already contacted the resource persons to find solutions for their difficult real-time situations. Thank you once again for your approach. Lastly, I thank all the members of the organizing committee. Without their cooperation and full support, this event would not be possible. Thank you, everyone. Thank you, ma'am. Thank you, sir.
Thank you, sir.
Thanks.